SA Water is now using machine learning to help forecast daily water demand for the Greater Adelaide network. A daily water demand forecast for the next 7 days provides important information to the Operations Control Group. It helps them to plan water production at each of the metropolitan water treatment plants, develop short-term network operating strategies, and to manage around network outages while maintaining customer service levels. SA Water and Stantec have been working together since 2012 to design, build, extend and enhance a suite of decision support tools for water network operations. This most recent project focused on geographic expansion and technology enhancements to the demand forecast tool. The original driver of the Decision Support Tools project was to help manage operational flexibility and complex decision-making on operations from source to tap. The main drivers behind the recent expansion and enhancements project were firstly, changes in business users' expectation of the tool accuracy and access for the business users to easily modify and update the tool as needed. Secondly, the availability of new data to train and validate the tool. And finally, the opportunity to use new machine learning tools and cloud technology to develop a new forecast model using different algorithms and climate variables. The demand forecasting tool can calculate water demand across the entire network at 30-minute intervals for 7 days. The tool uses forecast weather data from the Bureau of Meteorology, historic demands, calendar information for special events or weekend, weekday, seasonal customer consumption data, customer type and customer location information. The tool firstly forecasts a whole of region demand and then breaks the demand down to the customer type and geographic location. A spatial representation of demand across Adelaide's more than 130 pressure zones is a key input to developing production plans for each water treatment plant and planning short-term network operations. The new demand forecast tool has been built using Microsoft's Azure machine learning platform. This platform gives users the flexibility to develop and deploy separate forecast models to cover the diverse regions of the Greater Adelaide network, retrain the models on different historic climate and demand data sets as required, and test and deploy different models using a range of algorithms and input variables to achieve improved forecast accuracy. The forecast models have been deployed as a cloud service with the models running each morning on a schedule to collect the latest weather forecasts, execute the model's calculation and publish the results back to SA Water Systems. Demand predictions are completed within 20 seconds with forecast and hindcast calculations per region completed each time the models run. Increasing regulatory pressures, availability of capital funds, reduction in operating budgets, and global water availability challenges are putting significant pressure on utilities to maintain levels of service to their customers while doing more with less in innovative ways. The demand forecast tool used by SA Water allows them to leverage data that is readily available to understand and forecast water demand more accurately for sustainable and cost-effective operations planning.
Australia's first full-scale groundwater replenishment scheme in Perth, Western Australia, creates a new climate-independent water source and increases water recycling. The scheme uses an advanced water recycling plant to treat secondary treated wastewater to drinking quality standards before it is recharged into deep underground aquifers and stored for future treatment and supply to the drinking water network. This recharge supply is then able to be extracted on a one-to-one basis and contribute to Perth's drinking water supply. While the scheme started recharging water in late 2017, the Water Corporation started trialling groundwater replenishment in 2010, supported by a comprehensive 3-year community education and engagement program. In 2014, the corporation started construction of Stage 1 of the scheme at its Beanyup wastewater treatment plant in Craigie, with capacity to treat and recharge 14 billion litres of water per year. An advanced water recycling plant was built at the plant site, supplied with secondary treated water from the wastewater treatment plant. The plant treats the water to drinking quality standards using a 3-step process: ultrafiltration, reverse osmosis, and ultraviolet treatment. 13 critical control points are positioned in the treatment process to monitor the quality of water passing through and safeguard water that does not meet standards from progressing. New recharge and monitoring bores were also built. Critical to the success of the scheme, which is currently under expansion, that will see it double its capacity to up to 28 billion litres of water per year, was collaborating with regulators to develop and regulate the scheme's management frameworks and ensure compliance with Australian guidelines for water recycling. As the first water project of its kind in Australia, the Water Corporation's groundwater replenishment scheme has made a significant contribution to the country's long-term security of water supplies by creating a new cost-effective, climate-independent water source and increasing the capacity to safely and efficiently recycle water. The scheme has also facilitated a step change in long-term water supply for Western Australia and potentially other parts of the nation by providing a technical pathway, community engagement strategy, and regulatory framework for other water providers to follow.
So historically it's been difficult for utilities to monitor low-lying assets because there's lack of infrastructure there, no power, and it's generally hard to get to.
We wanted to be able to monitor the level in these retarding basins to, be able to provide warning to the public in the event that we were going to breach the levee bank.
They needed to do that without the use of power, and they wanted to do it quickly and within their budget constraints. Sage engineers bring innovation through other industry sectors to the water industry using Internet of Things to solve traditional problems.
It's the Internet of Things, connecting our energy-efficient field sensor devices via 3 or 4G, then using a cloud-based system to monitor it, all without traditional infrastructure. Stratus is a cloud-based SCADA system. It's running on Amazon AWS, and it's running ClearSCADA, which is a very popular SCADA for the water industry.
The innovative part of the project using Sage Automation and their Stratus solution, which is based on the cloud, allowed us to roll this out in real quick time.
Stratus is used in a wide range of industries, anywhere from the rail sector to smart cities.
Technology plays a great part in what we do in the water industry at the moment. I think Melbourne Water, through Russell and other people in the organisation, we like to embrace the technologies.
The devices are battery powered and solar powered, so they're designed to last 5+ years. You can put them out there for 1/10 of the cost of a traditional RTU.
Using Stratus in the cloud enabled the project team to stand the project up quickly.
It's a good demonstration project of the capabilities of moving to the cloud.
And our people get a real buzz out of working on projects that impact the community in such a positive way.
I'd like to say that it's been a pleasure working with SAGE and ALS for that matter to deliver this solution. Adoption of these technologies will be vital in the future for the water industry as they face population growth, ageing infrastructure and water scarcity.
It just allows us to see things that we haven't seen before and we had no knowledge of. Now we can see sort of near real-time data to monitor flooding, and we'll be able to make predictions based on that into the future to help relieve flooding in Melbourne.
I think the water industry now knows that you no longer need to be constrained by anything. You can use your imagination to get a level, pressure, trend on anything.
The innovative solution that SAGE come up with, the strata system, is excellent.
I think it benefits all the ratepayers, Melbourne Water as an organisation, and pushes technology that we can embrace.
Molonglo Valley Interceptor Sewer Rehabilitation joint project between Interflow and Icon Water. The project involved the structural rehabilitation of 913 metres of sewer, critical in carrying 2/3 of Canberra's wastewater. The precast reinforced concrete pipes were constructed in the 1970s and had begun corroding through exposure to sulfuric acid. With pipes measuring 2 metres in diameter, the project meant installing a structural liner larger than the product limits that had ever been attempted in Australia in a fully operational sewer. Innovative work methods were adopted, pioneering product development was applied, and lateral thinking was employed by Interflow. The project presented a range of challenges that Interflow solved by applying innovative solutions and technical expertise. Key project highlights include no bypassing required in a high, fast flowage line, no service interruptions, and no safety or environmental incidents. The sewer remained fully operational during works. Sewer work occurred off-peak, taking advantage of low flow periods. The works were in the vicinity of residential housing and had a minimal impact on local traffic and residents thanks to highly detailed plans and community engagement. To rehabilitate a sewer of this size without interrupting service, Interflow partnered with Sekisui Riblock Australia to reconfigure and adapt the industry-leading Rotorlock lining machine. Innovation was employed to stabilise the machine at that large 2-metre diameter to make it practical and safe for use in a high-flow environment. Other innovations included the use of HD profiling for detailed surveying to provide safer and faster information than traditional traversing. Cleaning methodology for the acid-attacked concrete surface to enable grouted liner to achieve a bond to meet stringent design strength requirements. Revolutionising the handling of a plastic profile strip in the high-flow conditions. The innovations applied and structural linings installed have sealed the pipelines to prevent further leakage, corrosion, water infiltration and root intrusion, and were engineered to accommodate all loads from soil, traffic and groundwater. To complete this project on time and on budget, Interflow pushed the boundaries in terms of scope, conditions and innovation to deliver results.
Engineering projects can truly be called cutting edge. However, the City of Logan's unconventional approach to improving drinking water quality is just that. Solar power, battery storage and electrochlorination technologies have been combined in a $3 million project to deliver safe, pure water to residents 24 hours a day. This innovation, an Australian first, is happening at Round Mountain Reservoir in the City of Logan's fast-growing southwest.
Round Mountain Reservoir is supplying a large growth area in the southwest of Logan, which includes a state government priority development area, which is planned to have about an extra 150,000 people over the next 20 years.
The 20 megalitre Round Mountain Reservoir is in the perfect location to service future growth. But today, it's 4 kilometres from the nearest electricity supply and only accessible by a 3-kilometre dirt road. Council's Logan Water Infrastructure Alliance stepped up to find a solution for water chlorination in this challenging location. The Alliance assessed a range of chlorination options, but one stood out as being the most sustainable long-term. This option was reliable, safe, and didn't rely on mains power or a sealed road for chemical deliveries. It also saved almost $2 million in capital costs straight away and about $50,000 a year in operating costs. Electrochlorinators would produce enough chlorine to treat almost 13 megalitres of water every day.
So this is where our process starts. We bring in bagged ultra-pure salt. That salt is lifted up in the bulk bags over to our brine tank. The bags are lowered down, the splitters open the bag and the salt drops through into the brine tank. The concentrated brine is then transferred over to our electrolysers. The electrolysers work by passing an electric current through that brine solution, and that produces hydrogen, chlorine and sodium hydroxide. The hydrogen gas that you can see bubbling there is vented, and the chlorine and sodium hydroxide react together to form sodium hypochlorite. These are our hypochlorite dosing pumps. They take hypochlorite from our bulk storage tank and transfer it into water leaving the reservoir, where it provides a free chlorine residual to protect the community.
Power comes from the sun, captured in an on-site solar array and stored in a commercial battery.
There are 323 panels on the roof that has sufficient capacity to produce 87 kilowatts of energy every hour. This is our 95 kilowatt hour Tesla power pack. It manages the output from our 3 inverters, and it has a battery capacity to meet the demand from the site for up to 3 days.
Solar power, commercial battery storage and electrochlorination is a smart solution for providing utilities in remote areas, cutting greenhouse gas emissions and delivering value to customers.